All right, good evening, good morning, good afternoon, wherever you are on this Flat Earth School of ours. Flat Earth School is around us 24/7 since the beginning of existence. I'm Mitchell from Australia. I've got a very special guest, Anthony Riley, sleeping warrior. How are you, Anthony?
Tired, man. I've only just woke up. It's been a late night. It's 11 a.m. in the UK at the moment, and it's the morning after the night before. So I'm a little bit rough, but I'm ready to go, man. I'm ready to go.
Never a better time to talk about something so in depth and
Yeah, slightly
and jam packed
hungover,
full.
feeling a bit cobwebby. Blow the dust off, and then let's talk about gravity. Whee!
All right, so today we're going to be going through relative density disequilibrium on one side of the argument, and the other side of the argument is asserted to be a downward force, whether it be gravity or whether it be electrostatic downward vector or any other sort of downward force. We're just going to be discussing that. Where would you like to go first, Anthony?
Let's talk about Einstein's equivalence principle. Do you remember what Einstein's equivalence principle is?
If you want to run us through it.
It's the claim that is, and it's a true claim, if you're in a lift accelerating upwards at a given rate, you would not be able to distinguish that feeling of weight from if you were in a position that is, and it's a true claim, if you're in a lift accelerating upwards at a given rate, you would not be able to distinguish that.
All right, so today we're going to be going through relative density disequilibrium on one side of the argument, and the other side of the argument is asserted to be a downward force, whether it be gravity or whether it be electrostatic downward vector or any other sort of downward force. We're just going to be discussing that. Where would you like to go first, Anthony?
Let's talk about Einstein's equivalence principle. Do you remember what Einstein's equivalence principle is?
If you want to run us through it.
It's the claim that is, and it's a true claim, if you're in a lift accelerating upwards at a given rate, you would not be able to distinguish that feeling of weight from if you were in a position where you're in a gravitational field being attracted to the center of mass. Now, that is a true statement, right? However, there is a massive, massive problem with it. And the big problem that we never consider is what do you think it is? Is there anything obvious, glaringly obvious, that's wrong with the statement? If you're in a lift accelerating up and then in a gravitational field, you can't tell any difference. Is there anything wrong with that?
Well, straight off the bat, you'd be begging the question that you're in a gravitational field, right?
Exactly. Straight away, you're begging the question that we are subject to either a lift going up or a gravitational field. Well, that's a false dichotomy, okay? It's a red herring argument. We're not in a gravitational field, and we're certainly not in a lift accelerating up, right? I know he means the Earth's accelerating up, and I know that is Einstein's position. But our position is that, well, hang on a second. We're not accelerating up. We're stationary. We're not moving, right? And we're not in a gravitational field, because Einstein said gravity is not a force. So then we're not in a gravitational field. So if Einstein accepts that we're not in a gravitational field because he says that gravity is not a force, then his equivalence principle has to be a false dichotomy. There has to be a third explanation. So we never talk about the possibility that it's a false dichotomy. We always accept that we must be now looking for a magical force. We must be frantically scratching through the closet looking for your old t-shirt that is your most comfortable one that you don't want to get rid of. It's in there somewhere. We're doing that by looking for the force, right? So it instantly makes you start looking for a force that doesn't even exist. Why doesn't it exist? Well, that's what we're going to talk about today. We're going to talk about why it is that gravity or electrostatic or incoherent dielectric acceleration, none of these things even exist. And they're just simply being regurgitated because it is simply accepted that we are either in a gravitational field or we're in a lift that's accelerating up, or the Earth's accelerating up, which doesn't work if we're on a ball, does it? Because I'm in England, you're in Australia. So if I'm in England and I'm accelerating up and you're underneath me on a ball, but you're also accelerating up, that means that the ball must be getting infinitely bigger all the time, doesn't it? Because that's what their model dictates, right? It isn't going to be doing that. So either Earth's flat and we're accelerated up the way that they criticize us, but that's what Einstein says, not flat earthers, or we're in a ball in a gravitational field, but then the equivalence principle can't apply because you can't have a ball that's continuously getting bigger because you're accelerating up at the same time that I am. That's nonsense, isn't it? Or there might be a third explanation that basically we never talk about because we're not told that the equivalence principle is a false dichotomy. There is a third explanation, and that's what we're going to talk about today. It's called relative density disequilibrium because it describes what it is that we're looking at. We know that that relative things to each other cause an interaction of some kind. We know that things relative to each other, a relative state, there is an interaction. Like if you have anything relative, so it is said that, and it is defined as such, that up, down, left, right, forwards, and backwards, it is defined that they are relative terms to what? To the human. So where does up come from and down come from? And it comes from the human. If you think about a fish will swim up and down in water. But up and down are not words in that fish's language if it was able to speak. It responds to pressure, to temperature, to light. So if you told a fish to swim down, he'd be thinking, what? But if you told a fish to swim to the more pressure or to the less light or to the colder, he'd understand that because that's language that he understands. But a fish doesn't have any concept of up and down. We do because it makes it easy for us to communicate. My left is your right. Your right is my left. So because they're relative only to the human, we have this paradox where we have the thought that there is a universal down, and the reality, we're trying to find a way to explain why we point in that direction when it's down. Suppose you lay flat on a bed and you're looking up at the stars. You're in your bedroom, you've got stars on the ceiling, and like a baby's room. And then I ask you to point down. Which way are you going to point? Because your down then would be the wall, the horizon. If I said point up, your up would be the wall or the horizon. But my up and down would be the ceiling and the floor, because I'm stood up. So which way is it? Is it that there is a universal down? Is it that there's a relative down? Or is it that there's no down at all? There's no up at all. It's all caused by the human. Today we're going to talk about how it's all caused by the human, and it's descriptive. It's a noun. You could even call it an adjective, but it's relative to the human. It isn't an absolute. There is no signpost in the middle of space somewhere that says this is the direction of down and then pointing. That's nonsense. If that's what you actually think, then you need to give your head a wobble. There is no absolute up and down. By definition, and also by practice in day-to-day life, up and down are relative directions to us. How would you describe the motion of a helium balloon that is let off by a hand at ground level? Typical example, you just let go of a helium balloon, but there's no humans in there. You're in the God position. You're in the clouds looking down, and there's no humans there. How would you describe that? The only thing you could say in the God position is that the balloon is coming towards you. Now, is that up or is it coming towards you? Well, you're in the godlike position looking down from the clouds. So the only thing that you can say is that's coming towards you. But you wouldn't describe it as up because you're not on the ground. Or would you call it up, even though you're in the clouds looking down? Now, ultimately, is this a semantical argument? Is it philosophical? You can make it into a philosophical one very easily, but it isn't. The simple fact is that we do not have an absolute up and an absolute down. Why? Because the human needs to be there to talk to the other human to be able to describe it. If there's no human, there is no direction. So we have to be talking about a different set of units, because things do move. Helium balloons do rise. Gases that are created at ground level through the biogeochemical cycle, they do rise up to the clouds. But if there's no humans there to describe that, then we need to know what is the explanation. So, relative density disequilibrium. Relative just means relative to something else. Everything exists in a medium, even if it's in a vacuum, even if it's in the most dense medium, like a super neutron star or whatever you want to call it in astrology. Astronomy, not astrology, astronomy. I always get them too mixed up. But anyway, everything exists in a medium. Science is doing its very best. These ball earthers, these anti-flat earthers are doing their very best to stop you talking about the medium, because there is a direct relationship with that medium. That's why some things float, some things sink, some things will hover. There is the relationship with the medium, and they never want to talk about it. So that's the reason why Einstein's equivalence principle is a false dichotomy, because it doesn't consider the medium. There is a direct relationship with the medium. I'll take an example of a golf ball and a ping pong ball. And the only thing that we're going to do is, and a steel ball of the same size. So imagine that you've got a steel ball, a golf ball, and a ping pong ball. Imagine that they're all identical in volume, but imagine, obviously, steel's more dense than golf, and golf is more dense than air, and air is the lightest one of the lot. In air, all three of them will stand on the bench, and they'll look like they're all sat in a state of equilibrium. However, they're all exerting a force that is different to each other against the table, aren't they? There's a downward force being presented against the table. Newton would argue that's being pulled by the center of mass of the Earth. Although it wasn't really Newton, but that's the argument. Einstein argues that the Earth is accelerating upwards, and that's what's creating the force. Well, is there a third? And the answer is yes. So if you've got those three same volume balls and they're all on the surface of the table and they're all exerting a force, you can get a set of scales and you can measure that force. And that force could be, it's a dial, isn't it? It's a wheel that spins and you put numbers on it. And those numbers can mean anything. They could be grams, they could be kilograms, they could be pounds, they could be tons, they could be any unit you want. They could be unicorns. It's just a unit. It's just a way of referencing something. So we accept that they cause a different force, but we don't accept what that force is and where it originates from, because it isn't being pulled to the center of Earth. Gravity doesn't exist as a force. Einstein told us that is the number one key point that people on our side need to remember at all times. Gravity is not a force. So it can't be the Earth pulling these masses down, because Einstein says so. Not that I agree with Einstein, but that's their current position in science. So if it's not being pulled down to the center of the Earth, then is the Earth accelerating upwards? Well, I'm not even going to entertain that as an argument, because it's nonsense. No one thinks that the Earth's accelerating upwards. And if it is, then it can't be a ball. That is a ball Earth debunk, because on a ball, it can't accelerate upward, because obviously it can't expand. So what is the explanation? And I wanted to know that myself. When I was doing my own research and you have to think critically, don't you? And I wanted to know, what is the explanation for why there appears to be different weights to things? And what I realized is that we're totally misunderstanding what is being pushed through the schools to the children. And let's be honest, the children are never going to learn that there is an equal and opposite argument here. Children are never going to be taught that gravity, Einsteinian or Newtonian, they're just going to be taught Newtonian. They're not going to be taught that Einsteinian even exists. So they're going to come out brainwashed thinking that things get pulled to the center of Earth, like I did back in the mid-90s. Obviously, I found out recently that there is an equal and opposite argument called Einsteinian gravitation. And then I realized that was nonsense too. So then I thought, well, what's the third? There's got to be something else to explain why these things have weight. What we would call colloquially weight. So let's go back to the three ball scenario. We've got the steel ball, we've got the golf ball, and we've got the ping pong ball, and they're all the identical same volume. We're now going to change the medium from air to water. The ping pong ball now floats on the water. The golf ball sinks to the bottom, and the steel ball also sinks to the bottom. So you've got two of them on the deck, and you've got one of them floating. What was the change that we made? It was the medium. Now, scientifically speaking, if you manipulate and change a variable and it causes the effect, that is the cause. Now, from a normal colloquial understanding, it's bloody obvious. You've flicked the switch, haven't you? You've changed the air into water, and boom, the ping pong balls rose. So straight away, you would naturally say that, well, that was the cause. The problem is, when you say that's the cause, they say, no. You've changed the amount of gravitational pull on the medium. Air is more dense than water is more dense than the air, and therefore gravity pulled on the medium more, and the ping pong ball took a thrust up that they call buoyant force. Logically makes sense. I can understand that. That's what children get taught. But Einstein said it's not a force. So buoyancy up thrust can't exist. So that nullifies the argument because of Einstein. Not that I agree with Einstein. I don't agree with Einstein, but that's what Einstein effectively does.
I just want to pause on the buoyancy part of this whole situation. So when I went through this with Craig, Fight the Flat Earth, with your egg test, which we will get to, he was saying that buoyancy is absolutely something that is in existence. And I said, no, it's not, because you need the gravity in the equation for the buoyancy. I don't believe you need an equation at all, and you don't need buoyancy at all. I used to be under the influence that it was density and buoyancy, but when you realize that gravity is built into buoyancy, buoyancy is not the thing that's making objects going up in that medium. It is just, as you said, it comes back to the relative density of the object in the medium and it's disequilibrium. And that's what we can science. So the situations that you gave us of Newtonian gravity, Einsteinian gravity, and then relative density disequilibrium, if we put these things through the scientific method, only one of these things can even have a valid hypothesis to test and be able to test, and that's relative density disequilibrium. The other two, Einsteinian gravity and Newtonian gravity, they're not science. They haven't been put through the scientific method.
Yeah, the simple fact is that if buoyancy does exist, and that is the explanation, it has to be the case that gravity is a force. Well, gravity is not a force. Einstein says so. The problem is people on their side refuse to accept that actually gravity is not a force, because it's so brainwashed into their mind that they dare not consider any alternatives. They will not accept that there is an equal and opposite explanation from any other source. They will always invoke gravitation as a force. Well, it's not me saying that it isn't a force. It's Albert Einstein, 1915, in his theory of general relativity, that is considered to be the science of today. It's not my position, it's his. So what I want to try and do now, I'm going to just to give some reference to this. How do I get back to that? So videos, just bear with me while I flick this open. Sort by all this first. Right, so do you want to flick over onto my screen?
Screen sharing, yep. Did you want audio in this?
No, don't need audio. on my channel, I had my channel deleted because I was on about COVID stuff, and YouTube took it off me. This video doesn't have enough views. It's worth way more views than what it's actually got. But it's 12 citations from current physics today. So we've got Brian Cox, Caltech, MIT, you name it, they're in there. But 12 citations that gravity is not a force. And this is applying Einstein. Now, for buoyancy to exist, it has to be the case that gravity is a force. But Einstein says gravity is not a force. So buoyancy cannot exist, right? Even if you calculate it as though it's a force, if you calculate for a force that's not a force, that nullifies your maths. You cannot have a calculation in maths that's supposed to represent reality if the claim by science states that the reality does not have gravity as a force. You cannot calculate for gravity to be a force if it isn't one. But that's what buoyancy does. So it's not okay for Craig to pretend that buoyancy exists, because if gravity isn't a force, buoyancy does not exist, and Einstein's the authority. Not me, Einstein. So let's just be clear. 12 citations in current science today, Caltech, MIT. I think I've even put the links on, maybe I've not. But they're all in there. But you look everywhere, like people in science at the moment seem to be flooding the internet with how gravity is not a force. Now, these are all people that are pushing the official narrative, and they're saying things like time is what gravity is and all this nonsense. What they're actually doing is they're further obfuscating the point. Don't come away with this topic with anything more than remembering that gravity is not a force. Because if you can remember that gravity is not a force, then that kills their arguments. And Einstein tells you expressly, he defines gravity to be the effect of the curvature of space-time. It's not me, it's Einstein, the effect of the curvature of space-time. Well, causes are not effects. Causes cause effects. You can't have an effect without a cause. You need a cause to get the effect. Well, if gravity is only the effect, in the equation F equals ma, it's the ma bit at the end. It's the mass accelerating that is what gravity is, the accelerating mass. But they need a force for that, though. And they haven't got a force because Einstein says so. Not me, Einstein. So let's knock off the screen share, because we don't need the screen share anymore. So what I want to do, so Fight the Flat Earth, Craig, insists, he jumps up and down, and he goes mental that gravity is a force and that buoyancy and upwards force, because we can calculate it as such. It's not true, Craig. Craig got a guy on his channel called George Musa. George Musa writes for Scientific American. He's a respected PhD holding theoretical physicist. His thesis was on how convection currents on Venus, blah, 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 whatever his point was. I don't know how he managed to get, I don't know, what was it, 50,000 words or whatever it was for his thesis on convection currents on Venus, when all we can see is it's a light in the sky. but he got a PhD out of that because it's pushing the narrative. It's nonsense. The reality is he came on Craig's channel and he was that polite in correcting Craig that gravity was not a force, that Craig thought he was actually agreeing with him. That's how brilliant that George Musa was at trolling that day. You don't need George Musa to go on your channel to correct you politely, to tell you that gravity is not a force. You can simply read any literature in science today and they will all tell you the same thing. They will all tell you it's not a force. They will all tell you that, and they'll even say that Einstein's not considered to be 100% correct. They think that there might be something else. Well, that tells you that they're going to feed you with more bullshit because they want more bullshit, more. That's what they're doing. They're feeding you with bullshit. Let's go back to the three balls. We've got the three balls that are, at the moment, we've got two on the deck in water and the other one's at the surface, right? So the two on the deck now, if we were to put put scales underneath them, the force that they were measuring is now significantly less. Why? Because the medium is influencing what's going on. Oh, there we go. Do you want to?
Yeah, I was going to play it.
Yeah, play it.
Yeah, I'm going to put the sound on.
But you can think of it as a.
Hang on, we'll go back.
Gravity is not a force, but you can think of it as a force. Maybe that's. Now, literally, it's not a force.
George Musa.
There we are.
So, what he's saying there is literally it's not a force, but you can think of it as a force. Well, that's because it exhibits the behavior of a force. We see it, but seeing it doesn't mean that we know the cause. It certainly doesn't mean that we can calculate the force and then ascribe it to gravity. What you're doing when you see an acceleration is you accept that F equals ma, you see the ma, and you want to know what that force is. Well, the problem is you always ascribe buoyancy or gravity to it. Yet, even though Einstein says gravity is not a force, well, logically, if Einstein's saying that gravity is not a force, well, why would you then ascribe gravity to it when Einstein tells you that it's not a force and he's the current position in science? That's what I did. What they do, what ball earthers do, is they insist that gravity is a force, and they'll calculate it even though what they're doing is essentially rejecting Einstein because he's inconvenient science for them. That's what morons do. Now, I'm not saying that I agree with Einstein, but what I am saying is that I took him on face value and I thought, well, if it's not a force, what is causing it? Because it's very intuitive, isn't it? Let's be honest. You see someone, you drop, mic drop, Neil deGrasse Tyson, and you can understand that there's an earth underneath pulling it. But really, if Neil deGrasse Tyson was being honest, he should tell you that if you dropped his keys in Mercury, the keys would float. Why? Well, we'll come to it. But let's go back to my balls for a minute, because we've got the three balls, two of which are now on the deck because they're in water, and one of them is now on the surface. Now, if we were to weigh the force that is being presented against each of the surfaces, you can say, well, that the steel ball seems to have lost a lot of its weight. I wonder what caused that. Maybe Earth shrunk underneath it. Now we just changed the medium. The golf ball now, it's only just touching the floor. It's very, very light. It's become the ping pong ball. And you wouldn't get the same way. You get a fraction of the weight that's pushing against the ground with the golf ball. But the ping pong ball's up at the top and it's floating. You'd have to turn your scales upside down and push down on the scales to get it to move and then measure the force. And then you'd realize that was significantly more heavy than just in the opposite direction than what the golf ball is. It's probably comparable to the steel ball. But the point is, you've got to turn your scales upside down and push down on them to get the resistance, because the water, the medium, is pushing against the ball. They insist that that's buoyancy, but gravity is not a force. So what is going on? The reality is you see the medium is pushing the ping pong ball against the scales, and you see that that is the cause of the force. But they've got you brainwashed and hardwired into thinking that that's buoyancy, even though Einstein says it's not. But anti-flat earthers will tell you all day that it is a buoyant force, and they will not accept that gravity is not one. You have to present them with 15 articles before they'll even consider it. Really, you only need Einstein's definition. Let's now change the medium to mercury. So we've gone from air to water. Now we're in mercury. All of a sudden, everything gets sent up. And I don't mean up as an absolute up. I mean it because we're describing it as up, because up's not an absolute direction. It's medium. It's to do with the human, but it's the medium that's causing this thing to go up, isn't it? So we've changed the medium to mercury, and now all three of them are all sat on the surface. Why is that? Because mercury is 5 times more dense than steel. So,
and can I point out if we lived in Mercury, there would with the same objects around us that we live in, it would appear that we'd had an upward bias.
Correct.
But we don't live in Mercury. We live in air around us, and there appears to be a downward bias. And in both situations, there is no bias.
Correct. So I'm going to come to another swimming pool example because we can all relate to it. It's very easy to relate to in a sec. But now we've got all three of them that are sat on the surface. And if we turn our scales upside down and we measure the forces that are being exerted against those objects by the medium, not by the Earth, not by buoyancy, the medium. If we measure those forces, the ping pong ball is now the heaviest of the items. The golf ball is in the middle again still, and the steel ball is now the lightest of the objects. It doesn't exert much of a force against the scales at all. Why is that? It's because the medium has changed everything. Now, if you understand that it's the medium that's causing that, because that is the thing that we changed, then you're doing science, because science has got definitions for these terms. These things that we're talking about now are defined terms in science. It's the independent variable. If you manipulate the presumed cause and it gives you the effect, right? You've got to manipulate it, and you've got to do it. So you have to manipulate the thing that you think that's causing it to see, does it cause the effect? And the answer is, well, yeah, that's what's happening here. Well done, you've just done science, because science tells you that the independent variable is the thing that you manipulate. That also excludes things that you didn't manipulate, being the cause. I didn't manipulate a gravitational field from the Earth, did I? I didn't make that mass bigger and smaller to change the amount of gravitational field. That wasn't manipulated. So you can't infer that. You've restricted to the thing that was manipulated being the cause. That means it was the medium. I also didn't bend space-time. I didn't change. I did actually, you can argue that I did change the uneven distribution of mass, but I controlled the mass that was being done. So it wasn't uneven distribution, it was controlled by me. But I didn't bend space-time by varying planets around the solar system and bending space-time in the way that light passes through that medium. All I did was I changed air to water to mercury. And I measured the results, and I realized, because science tells me the thing that I manipulate is the cause, then all of a sudden it all makes sense. There was no gravitational pull, there was no buoyant force. It was literally the relative density of the object in the medium it's in. That's why the golf ball of the same size as the ping pong ball is the same size as the steel ball. They all behave differently because their own individual relative density in the medium it's in was different. That's where the disequilibrium comes from. So if we screen share again. This is essentially what I wanted to know when I did my my research, because I wanted to know, why did things move? What is the thing that makes something move? Because I do accept that if a mass accelerates, ma, then you need a force to do it. You need something that's going to push against it. So I accepted that. And in this video, what I did, once I realized, I got 10 citations for the independent variable, because I anticipated that anybody that believes in gravity, I anticipated that there would be resistance against this, because the thing that I'm manipulating in this video with the egg test, I was manipulating the density of the medium directly, right? And I knew that anybody that wanted to believe in nonsense, hocus pocus gravitation, they would pick issue with it. And I got a lot of flack. But I put in this video, and I'll just see, I'll have to just click my way through it, but I put in 10 citations from different, like University of North Carolina. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. So we're seeing things move, and in this test, we're going to see something move. So the dependent variable is the egg accelerating, and the independent variable is me manipulating the density of the medium. The independent variable is the presumed cause, whereas the dependent variable is the presumed effect. Cause and effect. So I got 10 citations from a variety of different places, all of which I got them narrated by different people. Did you do one of them, Mitchell? I'm not sure if you did one of them or not.
No, it wasn't me.
It must have been before your time. But all of these citations were put in there, 10 of them, they were put in there on purpose because gravity is not a force. And if we manipulate the independent variable and cause an effect, then we're doing science. So what I did was I realized that weight, because you got to remember that weight is defined in physics, it's mass times the acceleration due to gravity. I remembered that weight is mass times the acceleration due to gravity. Well, if there's no acceleration due to gravity, then that nullifies their weight arguments, their weight formula, in the same way that it nullifies their buoyancy formula, because you need weight to have gravity, you need buoyancy to have gravity. Well, if you haven't got gravity, you haven't got weight or buoyancy. So that was, for me, I wanted to know, why did things move? So this is the phenomena that I noticed, is that things appear to float, things appear to sink, things appear to suspend within their medium. So depending on what, you can think of 101 different applications to this, but like in air, most things sink, but not all things. Steam rises, smoke rises, temperature, like that rises. Like if you've got a heat source, it warms the room through convection currents, so the heat from that temperature source rises. Steam, vapor, water vapor evaporating from the surface of the water caused by the sun, that vapor rising off the water, that rises. Not everything falls in the medium of air, but in real life, things do go up in the medium that we're in, and they completely ignore that. But I wanted to know, what could I cause it? That was essentially the question, could I cause it? So things appear to float, sink, and suspend in the medium of air. Most things appear to sink, but not all. So my hypothesis was that if I change the medium's density, the egg will move. The null hypothesis is if I change the density of the medium, the egg will not move, because your null hypothesis is the opposite of what you're claiming. So if you're going to claim that there's an incoherent dielectric acceleration and you're going to prove it by passing a current through something and then it does it, then great.
We've lost you for a second, Tony. Oh, Tony's gone. Well, while Tony tries to return, I just want to point out that this is the scientific method. It is not a scientific method. It is not Anthony Riley's scientific method or Quantum Erasers or my scientific method. This is the scientific method, the one and only. Hang on. Anthony is trying to come back, but he seems to be having some difficulty. There we go. Got you now, mate.
I've no idea what happened there.
Something blew up. All right, we've got you back. Your screen share has gone.
Put it back on.
Try and get up. That's mine. Yeah, that was your end. I was just saying that this is the scientific method, the method that everyone needs to put something through if they want to empirically prove something. And this is what you're about to do here.
Yeah, because if you can prove scientifically, empirically, that the cause of the effect is the thing that you're manipulating, then that opens the door to other people to then prove that you're wrong by repeating it and getting a different result. Or it encourages people to say, nah, mate, you're correlating there, mate. It's like when plants grow, right? Plants need sunlight, nutrients in the soil, they need temperature, something else that they need as well. And if I came along in the plant life argument and said, you only need sunlight for a plant to grow, look, here's my plants and I'll grow it. And then someone says, no, look, if I put sunlight on a plant, but I put it in the freezer, it'll not grow because it needs temperature as well. And they prove then that it's correlative. So when I do this test, I do two things. I'm putting out my flag and I'm saying it's the medium that causes it. And if someone disagrees that the medium causes it, they can prove me wrong. But they can also say, nah, mate, you've only correlated there. There's three things that cause this same effect. And you've only picked on one of them. And so far, it's been up for 2 years, and nobody has managed to prove that there is an equivalence. There is a correlation effect here. Nobody. So this is a winner. This is now it becomes peer reviewed because it's been published. It's been peer reviewed by all of my peers, and they're all anti-flat earthers, and not a single one of them has been able to prove that this is a correlation. Right? They don't like it because it proves that the medium is doing something. But this is science, right? This is what science is. And I realized that we were being passed an equivalence and I didn't like it. But I wanted to know what was causing it. So I've got my phenomena, I've got my hypothesis, I've got my null. So if I move on to the next scene here, I've identified expressly what my independent variable is. My independent variable is the density of the medium. So if I can manipulate, and you can do this 4 ways, you can change the density of the medium or the volume of the medium and keep the density the same. You can change the density of the subject, in this case an egg, or you can change the volume of the egg. And this applies everywhere. We can see it everywhere, but you never think about it. Plimsoll lines. Plimsoll lines on a boat show that when a boat travels south, it won't centrifugally be flung towards away from the earth because it's centrifugally spinning. It'll sink in the water. So if you're going from England with a cargo full of English steel and you're taking it to the Caribbean, you'll load it up to your Plimsoll line. But then when you get to where you're going in Bahamas, for example, you're now in the medium of tropical water instead of cold salt water. So the change in temperature and the salinity that goes with that makes the water in Bahamas significantly less dense. Now, if you don't realize that and you haven't got a Plimsoll line in your boat and you load it to what you think's safe in England, your boat's probably going to sink by the time you get to the Nassau in the Bahamas because the tropical waters around the boat have become less dense. They're warmer and they're also less salty, apparently. I don't know how true that bit is, but the temperature change causes the water to be less dense. Well, that makes the boat more dense relative to the medium it's in, and the boats were sinking. That's why Plimsoll lines came into play. So aside from that being an Etvos effect debunk, it's also a real-world application of relative density being demonstrated because it is the density of the medium that the boat sits in. And if you change the density of the medium, and bear in mind the boat's burnt fuel to get there, so it's got to be lighter by the time it gets there. The reality is it's sitting lower in the water, but their model claims the Etvos effect proves that the rotation of the Earth can be demonstrated with east and west cargo journeys, but with north to south ones, the Plimsoll line debunks that. But the point is that the medium is making the boat appear more dense, but the density of the boat didn't change. Well, it did. It got less dense because it burnt fuel. But because the medium's changing around the boat, you can make the boat sink if you overload it in England. Because by the time you get to Nassau in the Bahamas, the reality is that boat's going to probably sink if you're too heavy by the time you've left port, because by the time you get there, the water around the boat has changed. Real world application. But anyway, identifying the independent variable, the density of the medium, right? So we can change the 4 factors. We can change the volume or the density in the volume, like the mass of the object or of the medium. There's 4 things that you can manipulate. Well, you can't really change the density of many things very easily, and you can't change the volume of things and keep the density the same. It's not that easy to do, but I can change the density of the medium. So I can change the density of the medium to see if it did something. And obviously, if it does, the egg will move. That's my alternative hypothesis. But if it fails to do that, then I have to accept that my null hypothesis is true. It did not cause it. So all I did was, I overplayed this on purpose, but here we go. This is the key bit. So all I'm doing here is I'm pouring the salt in the water and the egg accelerates up. Now, if you think about what's actually happening there, I'll play it again because it's all done in a couple of seconds. But if you think what's actually happening there, you've got salt granules falling from above. If you're the egg, you've got salt granules that are falling from above. Let's just turn the speed down on this so that you can see it. Turn it down to 25. So you've got salt granules falling from above. It's raining salt, right? But for some reason, the egg wants to go the opposite direction towards that incoming mass. See, the egg doesn't move until the salt gets to underneath it. And then all of a sudden, the egg starts to accelerate. And obviously, I then realize I've poured far too much in, and I didn't need that much. But the point is made that if I increase the density of the object, the egg will accelerate. So what's really happening, if we go back to a couple of seconds, what's really happening at this point is when I've got the egg sat in this suspended medium now, the egg's not accelerating. It's undergoing Brownian motion, and Brownian motion is shivering, basically. The egg's moving microscopically at the atomic level. It's moving microscopically, but it's sat on a layer of density underneath. Brian's logic would call it structural support. But you've got to realize what it's actually doing is that the medium is pressing against the sides of the container and all surfaces evenly. But the medium itself is not even. It's a density gradient. It's an ever so slight density gradient. So before I pour the salt in, the egg is sat on pressure, pushing up from the molecules of water, pushing against the sides of the glass, but also against the bottom side of the thing, the egg. So that's why it's sat in the middle. Now, the theory is if I add mass to it, and then I know that salt's more dense than the water, so it's all going to go down. And you see that if I add the salt and it all sits below you'll notice that nothing happens when the salt's above. It's only when the salt goes below the egg that things start to change. The minute it gets below the egg, what is happening? Well, it's in a gradient. It's sat on its layer, like in the density tower. It's sat like little cherry tomato somewhere in the middle. And then if I add mass above it, I'm increasing the pressure above it, but there's not enough of a pressure there to make a difference to push it down. But because it's sat at its equilibrium point, and all of the mass that I'm putting in it is going below, all of it, you see it, it proves that the force is pressure, because pressure is a force. It's increasing the mass per unit volume below the egg, not above it. It's falling through that. It gets to below it. And then the minute because it instantly starts to dissolve as well. So when I pour it in, it's starting to dissolve straight away, but it's not putting enough pressure at the top to push it down. It's only when it goes below the egg, because the egg sat in its layer. If you accept that pressure is a force, and tires have pressure in them, pressure is a force, this is the cause for what's really happening here. And relative density disequilibrium is demonstrating it.
And the disequilibrium part comes in when you have changed that medium. So it was sitting in equilibrium when it was just floating there, and then you've changed the density of the medium, and then it's in the state of disequilibrium, causing it to move.
Yeah, so by adding the mass, you change the equilibrium point, right? Because you're adding mass to the volume. But the mass that I'm adding is all going to the bottom of the glass. It's dissolving as it falls through. And obviously, if I leave it long enough, it'll dissolve completely, or unless it gets to saturation point. But essentially, it'll dissolve. And as it's dissolving into the medium, then basically it becomes the medium. So you're adding pressure below the egg. Now, initially, when you first pour it in, the pressure's at the top. But because you've got loads of headway at the top, you've got no headway at the bottom, because the egg sat in its equilibrium point. It's sat on a cushion of pressure caused by the medium. And that's why the minute the pressure goes past the egg and it hits the deck, all of that pressure is now at the bottom and it's pushing up, it's dissolving, it's creating more mass per unit volume, but it's all below the egg. So it's pushing the egg up from underneath. They would conflate that with buoyant force. But the problem is, on their model, if it was buoyant force, the problem is, one, if Newton's gravitation is pulling on what's it going to pull on in this instance? Is it going to pull on the egg, or is it going to pull on the medium? And they say, well, it's pulling on the medium because that buoyant force is the upthrust that the egg gets, and it matches the weight of the volume, the weight of the salt that you're putting in. Okay, so that what they're doing is they're saying that gravity's pulling on the medium, pushing the egg up. But we know gravity's not a force, so we know that that's not it. So what is the explanation in terms of, like, why are they wrong? Well, aside from the fact that gravity is wrong, gravity's not a force, they are wrong because if the Earth is underneath the egg and you've got the mass of the Earth pulling on the egg, and then I add more mass below that egg, you've got the mass of the Earth plus the mass of the salt equals a bigger gravitational force on the egg. And they say, no, it didn't pull on the egg, it pulled on the medium. Then my question is, how did it know to switch? What was it that told gravity to pull on the medium, not the egg? Because they say mass attracts mass. They don't say that mass attracts mediums. But when something goes up, they go, oh no, it attracts mediums now. Really? So how did it know? And the answer is, it doesn't, obviously it doesn't know, but I'm changing the mass. I'm changing the mass that's in the volume. That is the cause of it. It's not little green men pulling it down or pushing it up from below. That's what they're claiming. It's not that. It's the thing that I manipulated. I gave 10 citations in science to describe it and explain it, define it, so we can all apply it. Now, if you dismiss this, then you're dismissing scientific method and you become a science denier. But you can validate this work yourself. You can repeat it. You know that this is going to happen. You don't even need to do it. It's so obviously going to do it again. You don't even need to do it. But if you don't accept that the medium change caused the acceleration, then you are a science denier by definition. Now, we're pushing science. We're trying to stop these guys from wandering off into a flight of fancy, inferring other causes, when the defined cause is the thing that I manipulated. Well, I did manipulate the amount of mass in that volume. I didn't change volume. I didn't change temperature. I did change pressure, because putting more mass in it causes the pressure. That's what the pressure is, isn't it? It's the amount of pressure pressing against the surfaces. Well, the underside of the egg is the surface that the pressure is pressing on. So by adding more mass to it, I'm increasing the pressure, and the pressure is pushing the egg up, because the walls of the glass can't flex. The only thing that can flex is the egg sat on its little layer of density, its average density, and that's what's happened. But they call that buoyancy, and it's not true. It's not scientific. It's to delude you into thinking that there's a force there. Well, there is a force, but it's pressure. It's not the buoyant force. Buoyant force doesn't exist. So what is it? Well, it's pressure. Pressure does exist, and I'm demonstrating it. It's caused by having disequilibrium between the object and the medium that it's in. And that is the reason why things accelerate. You can do this with other things. Let's go back to, for a moment, and I'll do it really quick, the three balls that we had before. We had a ping pong ball, we had a golf ball, and we had a steel ball, and we did it in mercury. Well, because mercury is pushing everything all the way up, you can see that that was the cause. Now imagine that we're in a deep swimming pool. At the side of the swimming pool, you weigh what, 70 kilos, 80 kilos, just say 100 kilos for easy maths. You weigh 100 kilograms at the side of a swimming pool. Chuck the scales in. The scales are more dense than the water. They go to the deck. You try putting 100 kilos on that scales now that's in the deep end. The minute you push off them scales, you go back up again. Now, let's just imagine that you stood at the bottom of the deep end of the pool, right? You're not on the scales, you're just off the scales, but you stood at the deep end. If I was to fill the swimming pool, let's say you're 6 foot. If I filled it with 8 foot worth of mercury, think about what's going to happen. Mercury is a lot more dense than the water that's in it. And if I fill the water from the bottom up with 8 foot worth of water, it goes over your head by 2 feet. The water gets pushed out of the swimming pool to represent the same amount of volume, because you're putting loads of mercury in. The water's going to sit on top of the mercury because it's less dense than the mercury. But your position is no longer tenable because the mercury is more dense than you. So you're going to go up with the water as well. Now, if you're able to exhale and get rid of all the air out of your lungs to make your volume smaller and you're more dense, you're going to be sandwiched between the mercury layer and the water layer, because the mercury layer is 5 times more dense than us and water, but we're a little bit more dense than the water. We're trapped. They would say we've got a force pushing up. Doesn't matter what they say. We're trapped in between 2 layers. We become the cherry tomato in the density tower. If you've ever seen the density tower, there's a cherry tomato in the middle. We become that cherry tomato in that circumstance, and it's recreatable. You just got to think about the medium. You've got to think, right, what is the cause? And it is the thing that we are manipulating, and you can demonstrate and experiment with this with lots of different things. Ping pong balls in air is a great example. Do you want to screen share again? Check this.
Yep, it's still on.
Experiment with other things in the medium of air.
I think we've lost you again, Tony. If you can still hear me. Tony, you still there, mate? So we've lost Tony again for whatever reason. Unfortunately, just getting to the crux of this argument where I want to pivot off it onto. So when we get to this point here, I think we can safely say and prove that Anthony's coming back now.
ISP.
Yep, got you now.
I
was just saying. I was just saying while you're reconnecting, I think we can safely say that we have put beyond doubt that there is no gravity. There is no force of gravity, Einstein or Newtonian, whatever you want to call it. There is no force that is attributed to these things that we are seeing. You've put relative density disequilibrium through the scientific method, something that can't be done with gravity, whatever you want to call it. And after we go through this last point here, there's actually a fourth argument, if you will, rather than so now we've put gravity to the side. The argument that the discussion that I was having with Bob from Globebusters last week was the other side of this flat Earth argument, which is so this side that you've been detailing is relative density disequilibrium, and the other side is electrostatic downward vector. But you can play this little bit first, and then we'll go.
No, it's okay. We can move on to it. All I was showing was that the cherry tomato in the density layer is what you would become if you were sat on the deck of the swimming pool and you filled it with 8 foot of mercury. You wouldn't be able to stay on the bottom because you're less dense than the mercury. You would be pushed up by the mercury, not by a buoyant force, and you would be sat in the middle between the two layers because we would then become the cherry tomato. That was the point I was making with the swimming pool. So let's move on now to the criticism. Now,
before we do, just with this density tower here, it was shown last week that this density tower put into what they call it a 0G environment, which that's a contradiction in itself. But if you put it in a parabolic flight where you're falling down and there's a density tower like this, it was shown in the video, the density tower decides to mix up for whatever reason. Why is that happening?
All right, so let's just clarify terms. We are at 0G. A plane falling out the sky is not at 0G. A plane falling out the sky is a plane falling out the sky, right? To call it a 0G plane is it's begging the question, first off. It's like Einstein with the equivalence principle. It's describing something as something else. Well, planes falling out the sky and the rate at which a density tower does or doesn't do something is a total and utter false equivalence because we're not in a falling frame of reference. We're supposed to be, according to Einstein, we're supposed to be in an accelerating frame of reference up. So what they should be doing to demonstrate this like truth of the real world is doing it in a lift. If they do it in a lift, that's the equivalent position that, according to Einstein, if we're in a gravitational field, everything pulls down. If you do it in a lift, that's essentially going up, but we're not in a gravitational field. So if we're not in a gravitational field and we do the density tower in a lift going upwards to represent Einstein's claim, does it change anything? And the answer, of course, is no. But if you pull everything down, all these layers in this density tower, they've all got different magnitudes. This is the bit that Bob doesn't understand and he refuses to accept. All of these layers have got slightly different magnitudes, right? Magnitude is a measurement of quanta. It's a measurement of weight, essentially. Don't quote me on the word weight. It's not strictly speaking correct, but they've all got different weights, and I'm using it in its colloquial sense, not in its scientific sense, because obviously in its scientific sense, it's a null term. Weight is mass times acceleration due to gravity. Gravity is not a force. Weight cannot be used in a scientific sense. It's null, right? In its colloquial sense, all of these layers have all got a slightly different weight. They're all similar, but they're all different. Also, these layers are immiscible. All these layers won't mix. So that immiscibility factor is something that needs to be remembered, because if they did mix, they would have one big cloud of whatever color that all them mixed together would get. But these are all separated, right? Which allows you to see the layers. Great. But the point is, if they're falling out the sky, the rate at which all these things fall is still going to be relative to each other. Now, I've only ever seen these density towers in a vomit comet when they get a nice jolt. I've never seen them when they're kept stable, because it would be an interesting test to do. And I'm going to say that the guys that were working for NASA doing the density tower test, when they were doing that, it's very convenient for them to mix it up by jolting it. Watch it carefully. Watch the video carefully. You can see clearly that it jolts, right? And the only two I've seen does exactly that, jolt. But it's a false equivalence in any event. we're not falling out the sky. So to claim that that represents zero gravity is nonsense, because gravity is not a force. You're not claiming that. What you're actually claiming is that a plane falling out the sky has weird effects. Well, okay, but it doesn't mean anything with respect to the gravity arguments. It's still a plane falling out the sky, guys. That's the bit that you must remember. Now, also remember, in that plane, when it's falling out the sky, the air in the plane inverts, because the pressure goes against the top of the plane, or the ceiling of the plane on the inside. Because we've seen how the car, I don't know if you've seen it with the helium balloon, as the car accelerates, when it's got a balloon anchored to the handbrake of the car, the car accelerates, but the balloon goes forward with the acceleration. Have you ever seen that?
Yeah, that's a great demonstration of what you're just describing.
Yeah, so what that's doing is it's buffering the weight of the air to the back of the car, creating a lateral density gradient where the balloon was sat in the middle. But then because the density behind the balloon gets bigger, it pushes the balloon forwards. And that's totally consistent with the acceleration of the car, causing a lateral change in the density gradient inside the car. That isn't what he's doing. It's pushing it all to the back. It's showing the inertia of the air against the balloon, because that's all it's showing. But when you first see that, it makes you think, what's going on there? Once you have that explanation, it makes sense. But the plane's doing the same thing. When the plane's falling out the sky, the pressure the pressure gradient of the air that's inside the thing inverts as well. So essentially, there's too many things going on. It's a false equivalence, and it doesn't address the point. The point that we're trying to establish is whether or not there's a force. Well, Einstein's already defined that there's not a force. So it's a total false equivalence anyway. Do it in a lift. That would be the equivalent position for Einstein, because we're not in a gravitational field. And he says that if there is a gravitational field, it's the same as going in a lift upwards. Well, you know as well as I know that these things aren't going to change in a lift. Yeah, there might be a jolt initially as the lift starts jolting initially. But if you could do it in a lift that was nice and gradual, and there wasn't that jolt in acceleration, nothing's going to change. Why? Because we're not in an accelerating, we're not in a gravitational field, and we're not in an accelerating frame of reference. Completely consistent. Did I drop them?
No, you're still here. Yep, absolutely.
So
all right, so now we'll get to the other side. This is where it becomes a flat Earth argument here. So we can safely get rid of any globe claims. There is no globe claims here. They can't be put through the scientific method. They are literally just so stories that have been taught to us for whatever reason. But now we can exclusively just talk about what is happening on our flat Earth here. So we've just gone through relative density disequilibrium. Have you put any effort or any theories of the electrostatic downward vector into this your egg test? I guess, is there any factors that is on that side of the argument that can be applied to your egg test?
There's three things to say in direct criticism of the claim of the incoherent dielectric acceleration argument. Number one is it's Bob's claim. So Bob's got to demonstrate that it does what he says it does. Now, I've challenged Bob and Zach to do a test, and they refused to do it. And the reason is the reason why they refuse to do it is because it proves their null hypothesis. They can reproduce the egg test in their kitchen. A little bit of kitchen worktop science does a lot of favors in this topic, because if you can demonstrate things in the kitchen, it makes it perfectly applicable for everybody. He can get a pint glass, or whatever you guys call it in America, because I know you don't use pints, but a stein or whatever. Reproduce that egg test and get the egg so it's somewhere in the middle, right? And I've done this, and this is why I've challenged him to do it. If he thinks that passing a charge or a current potential through the medium, if he thinks that that causes an acceleration, then he should be able to reproduce it with the egg test. Now, I've reproduced it and it does not work. Now, the problem with passing a current through the egg test is if you leave it on long enough, it starts electrolysis. So you can't do it like the way that his test would require doing, like proper. So you have to make and break it. You have to make contact, remove it, make contact, remove it. And what should happen if his test is correct is that the egg should start to move up and down in its medium, because you're putting voltage in, voltage out, voltage in, voltage out. and that will be manipulating the presumed cause, voltage. And that is repeatable. We can test it. I've tested it and it does not work. So I've challenged Bob before and he completely ignores it to reproduce the egg test on his bench with a car battery, put a bulb in the picture so that you can see when it's being connected, so that the bulb does light, and then you can prove that the current's passing through it. And he won't do it. Why does he not do it? Because it forces the null hypothesis to be accepted. The problem with Bob's test is that gravity is proportionate to mass, but the incoherent dielectric acceleration argument is not proportionate to mass. Now it does exist. We can create a static charge with a balloon, rub it on your head, rub it on your shirt, and then stick it on the wall, and it'll stick on the wall for a period. We can all do that. Nobody denies that it exists. The problem is it's not relative to the mass. It's not linked to the mass. It's not because it's disproportionate to mass. Gravity is proportionate to mass according to Newton. Bob's incoherent dielectric acceleration is disproportionate to mass. It does exist, but it's such a small charge, such a small voltage, such a small magnitude that it's insignificant. So what does that mean? It means that a baby can get a toy and it can move the toy around because the baby's got very little strength and the toy is very light. But a baby can't pick up a dumbbell from a gym set, a home gym, and a baby can't move that around because it's not got enough power to do it, right? We can all accept that. A baby can't push a broken down car at the side of the road. It can't push a locomotive. Bob's incoherent dielectric acceleration is the baby, and it can pick up the rattle, the toy, and everybody accepts that. But because it's not proportionate to mass, it can't be the kick that he claims it is, because it has to be proportionate to mass to be the difference between up from down or acceleration from not acceleration in every instance. So it has to apply to the egg if it's the kick that he claims it is. And he can test it, but will not do it because he has to accept his null hypothesis that the voltage or the charge or the current or the whatever you want to call it, the passing of a voltage through the medium does not cause the acceleration. Yes, it causes it with a little fleck of paint between two things, and I've seen him do that test, but it's disproportionate to mass. Therefore, cannot and is not the reason why there is a up and down. The reason there is an up and down, Bob, is because the human puts it there. And the reason why things accelerate is because we can manipulate and vary the density of the medium or the object, and we can cause the acceleration ourselves. But by way of extension, I've tested your theory, Bob, and it does not work. So Bob can test it, will not test it, because he hides from the fact that it will prove his null hypothesis to be true. He will be forced to accept the incoherent.
We're starting to lose you again, Anthony. If you can hear me, you're breaking up. Starting to lose you.
Am I back?
You there, mate? You were back. Nope. All right, well, while we're waiting for Anthony to rejoin, I just want to point out that we've been going over relative density disequilibrium, and at no point in that discussion was there any sort of a bias in a direction. Hey, Anthony, I think you're back, mate?
Yeah.
Yep, cool. So to assert that there is a bias of down, which is, as you said in the start of this discussion, that down is a relative position or a relative motion, relative direction.
Yeah.
If there is a bias of down, then a bias is something that happens at least the majority of the time, if not all the time. And when I was talking about this to my children today, because we were just out and about, we were looking at maybe a waterfall or something, and I was just explaining, look around us, can we see anything going down? And they pointed out that, yeah, maybe rain goes down, maybe waterfalls go down. But if we look around us, other than the waterfalls and the rain, because they're just trying to find their equilibrium, they're in a state of disequilibrium, trying to find their own equilibrium. in the medium of air. I pointed out, if we look around us in our natural world, things are not going down. If we're not standing near a waterfall, if it's not raining, we look around us, and if anything, the majority of things will be going up by just the nature of gas. Everything, I tried to make the example that if things are going down, then they have started from down in the first place, and they've been forced into a position of up relative from that down. Everything has that we naturally know in our world. There may be some examples of contrary to this, but everything that I can think of, it started at ground level, it's been forced into a state of disequilibrium, and it would be going down because it is in that state of disequilibrium. Now, whether it be something that's growing, like a leaf on a tree has started as a seedling, it's grown up, it may appear to be in a state of equilibrium because nothing's falling, but as soon as something detaches from that tree, that structure, it will want to go back down to where it started. Just like the water cycles, just like the gas cycles, gas gets produced at the ground level. It is definitely not accelerating down. It accelerates in all directions, evenly and equally in all directions. It doesn't have a downward bias. So we look at things like puddles. Puddles don't stay there. They evaporate. They're part of the water cycle. They start from down. They get put into a state of disequilibrium, and then they want to find their equilibrium. That's just what everything that we see. That's how we can demonstrate things. So I challenge anyone to find something that only goes down that has started from up, because my claim would be that everything has started from the position of the ground.
At the end of the day, the only way, let me just finish the point that I was making before I got kicked off. Bob is able to demonstrate his claim, but he will not do it because he has to accept his null. I've tested Bob's claim and it doesn't cause any acceleration. Now, because Bob's incoherent dielectric acceleration point is not proportionate to mass, it means that it's got very limited application, very, very limited, incredibly small limited, and it cannot be the kick that he claims it is. Because if you think about the baby example with the rattle, a baby can pick up the rattle because it's very light, but it can't push a broken down car, it can't push a locomotive, it can't push a plane. I'm exaggerating this for effect. Nobody disputes that a baby can pick up a rattle. But is it the reason why a plane will start to accelerate if a baby starts pushing against it and fails to get the locomotive or the plane to accelerate? And the answer is, of course, no, it isn't strong enough. So because it's not proportionate to mass the way that it needs to be, if it is the kick that he claims it is, then it doesn't apply in anything unless everything's in equilibrium, but everything's relative. So Bob's position is wrong. Now, with respect to what you said, if we could see the movement of gas molecules, and we could see how gas was being created and how it was convecting in our atmosphere through the biogeochemical cycle, if we could see that and we could see the currents, then there wouldn't be this argument. But the problem is gases are generally invisible. You do get the odd one or two that you can see, like bromine gas, for example, but most gases, you can't see them. How do we know that they're there? Because they give us pressure, and that's how we say that we are breathing, because the pressure must be pressing against something. It doesn't have to be a dome, it doesn't have to be a square cube or whatever, but it has to be pressing against somewhere, otherwise the gas escapes. And we all know that to be true. But the reality is, if we could see, if you think about a fire in a room, think about a big room, right? And you've got a small fire. And where do they put fires? They're always at ground level. They never put fires in the middle of the room. Or
We're losing you again, Anthony. Cutting in and out. All right, so while Anthony tries to reconnect again, I want to make the example of, we don't see gas as per just by the nature of gas, you don't see gas, just our eyes don't pick it up. We do observe that a puddle on the ground would disappear, and it is definitely not going down. It just doesn't disperse down. It disperses up when it's evaporated, when entropy, the opposite of entropy takes effect. So the sun is the entropy generator or some sort of heat source. It evaporates, it starts the cycle, it gets put into disequilibrium. Tony's gone all together now. We see smoke, we do see steam, we see these things that are not going down and not necessarily going up. They could be suspended in the air. They could find their equilibrium within the air. And it just keeps coming back to the point that relative density disequilibrium explains the things that we see. It can be put through the scientific method and has been put through the scientific method. But on the other side of the argument, the downward vector, the downward acceleration, that hasn't been put through the scientific method. I'm not sure if it can be put through the scientific method. To date, it hasn't been, and they do admit that to their credit. They're not trying to push that it is science. But on the side of the argument of relative density disequilibrium, it has got the backing of the empirical method being science. I think Anthony's trying to join again. So Arwen in the chat says, all objects that are not in equilibrium, so that is disequilibrium, in their medium, have a constant force applied to them, even if they are stuck to something else. So if something is in a state of disequilibrium, but is blocked by something else, when that blockage has been moved, or the object still seeking equilibrium has overcome that blockage, then it will continue to go to equilibrium. So people make the example of the coffee cup on the table. So the coffee cup on the table, some could say that it is at equilibrium, it is at rest. Some would say there is still a force being applied to it. But that does not become apparent until that blockage of the table is removed, or somehow the coffee cup overcomes that blockage. And then when it's not being blocked by the table, it will continue on its path to equilibrium, wherever that may be. Now, just going back to the globe model with gravity, where would that stop? If there was somehow a big, massive gaping hole and the coffee cup was allowed to just fall continuously, if it was getting to the center of that presupposed spherical Earth, what would happen? It's things like this that send us into that begging the question. It is situations that we just can't get to. We can only experience what we experience in our reality around us. I'm hoping Anthony's going to be rejoining, because we were in the middle of the conversation of just pitting these two arguments against each other. And this is the flat Earth. This is a flat Earth exclusive conversation. This doesn't require any globe rhetoric. It doesn't require anything from the globe side. This is just a conversation that we're having on the flat Earth side, because we're trying to figure out why it is that, when we see things going towards the ground, why that happens. And I think Tony's done a good job of not only describing why things will move, and it's not only just down, it's up, it can be left and right, but to prove why they are happening. He's had his dependent variable of things moving. So we do absolutely see things moving, whether it be up, down, left, right, forward, backwards. And the cause to those things moving, he's isolated as the density of the medium that thing is in. So he's egg test. Hopefully this is Anthony. Apologies, everyone. Nope, Anthony says it's his ISP that's the problem. Out of his control. All right, we'll see if Anthony comes back in. If not, probably can't go much further. That was a great conversation on the side of relative density disequilibrium. We can't get too much further into the other side. It would be great if we can have a proper conversation between these two arguments on both sides. Bob on one side being the electrostatic downward vector, and Anthony on the side of relative density disequilibrium. If those two people, because let's face it, these two people are on the polar opposites of these arguments. They are, that's what they have been investigating for years now. They know the arguments well, they detail them well, and to sort out this situation that we find ourselves in, I think it is people like this from either side of the conversation. We can't just have these one-sided conversations where we've got just Bob in talking to someone, or we've got just Anthony talking to someone. These things need to be sorted out when these two opposing sides can just have a good civil conversation about the flat Earth world around us. Owen says his last comment is an important key. So what is calculated as weight is actually persistent relative density disequilibrium in a ground level standard pressure air medium. So yeah, weight is all just relative to the medium that it's in. Anthony was bringing up if we had a scale, a kitchen scale in air, and we stood on it, and then we have a kitchen scale in water and we try to stand on it, it's going to read different weights. That's what. So it brings me to a topic that probably 3 years ago, there's a guy called Stephen Noxie. He used to be a co-host with Paul on the plane. He was doing these observations where he had I suppose a ball, some sort of container, so a container of a specific size. And we've got Anthony Riley back here. I was just describing what I don't think you heard of Stephen Noxie. I was just describing what he. So a couple of years ago, yeah, I was just saying that he was investigating what he called a separation force. So he did some observations where he had let's just call it a container. So we'll call it a 1 liter container. So he put water. He filled up 1 liter of water in that container, and he had a scale which was in the medium of air, and he weighed that 1 liter of water. And then he emptied that liter of water and he sealed the container. So we've got 1 liter of air, if you will, and he submerged it in the water and he inverted the scale. So at the barrier, if you will, of where the water meets the air, he turned it upside down and it read the same reading. And that's kind of, he was doing some investigating through a lot of different mediums. He was getting together a paper. It was getting peer reviewed by actual established scientific bodies, but for some reason, that's where the conversation stopped. He didn't actually release any documents. He was just doing these observations. He was describing what he was seeing, and it's really unfortunate that he has kind of left the scene for a while, because this is it's probably a good 3 years ago now, and that conversation could have really developed from that point to enter into something like this argument. It is just these separation forces that we can measure in different mediums.
I'm not familiar with that guy, but let me just explain that my ISP today is acting daft. doesn't normally do this. I don't know what's wrong with it. They must be doing work on it, but it's not me doing stuff wrong. It's the ISP. Yeah. So the problem with Bob's main argument is essentially that because that static charge that we all accept exists, we can all demonstrate it with a balloon. Because it's not linked or proportionate to mass, it can't be the reason why things become up or down. Because if it was the things why things move up or down, it would be proportionate to mass. And because it's not proportionate to mass, it only affects masses that are extremely small, in like a fleck of paint size, and therefore it isn't the reason. If it was, it would work with the egg, but it doesn't work with the egg. And I've tried to get him to do it, and he won't do it. So for me, and it's demonstrably the case that it's not proportionate to mass. So Bob's got to get past how is it proportion? How is it the reason for it being up and down when it's not proportionate to mass? Because it isn't the reason for up and down. It does exist, but it's a minuscule force, like a baby trying to push a locomotive. That's the problem with it.
So do you think that electrostatic downward vector, or the dielectric, I'm not sure how do you refer to is it incoherent dielectric acceleration? Do you think that can be put through the scientific method? Is there a way that they can validate that scientifically, empirically?
Yes. So his claim is that the air carries with it a charge. He calls it a current. It isn't a current. It's only a current when it's lightning. It jumps the gap like a spark plug. The sky's acting like a capacitor. The charge potential builds up in the capacitor over a period of time, charged by the sun, and eventually we get a thunderstorm, and that's where it discharges the capacitor, the sky's nature to act like a capacitor. So when lightning strikes, or when lightning arcs the gap, that's the capacitor releasing its energy in a short, sharp bump, exactly like a capacitor. But Bob describes it as a current, a downwards flow of energy, and it's not. If it was a downwards flow of energy, there would never be any lightning, because there would never be any charge potential building up in the first place. So Bob's description of it being a flow or a current flow is not true. Because it's not a current flow, there isn't any flow from the sky. The only time there is a flow from the sky is when it's lightning. Now, to answer your question directly, is there a way that you could scientifically demonstrate his claim? Yeah, this is why I've said to him he needs to replicate the egg test. Because if he did replicate the egg test, he would see that it does not cause the acceleration that he believes pervades everything, and therefore he would have to accept the null hypothesis. Well, unfortunately, Bob, that's not the explanation, or it's not the.
And we'll lost you again, Anthony, if you can hear me. High speed's playing up again, mate. Unfortunately. So someone in the chats, Arwen in the chat says weight is actually air weight. There's also water weight. There is a vacuum weight used in the industry. So yeah, it is all relative. Weight is relative to the medium that it is in. It is not just, it's not just weight is weight. And on, I suppose if we go back to the globe argument, yeah, that they say that weight is not the thing that it is really mass. Mass stays the same, and they do describe being in different mediums as something that changes the weight, but that we don't need to ascribe anything to do with gravity or anything to do with a globe or really anything to do with a vacuum, because a vacuum is a man-made thing. Nature abhors a vacuum. That means that you will never find a naturally occurring vacuum in nature. Gas pressure will always want to flow from high pressure to low pressure. That's just a fact of our world around us. Yeah, gas has no inertia. It can't be to be influenced by an external force. So entropy is the only. Just saying if Anthony's not joining. That was a great conversation. But when I talk to my children about these sorts of things, I want to. You have to be able to describe these things in a way for children who are just hearing these arguments, who are just trying to investigate, just starting to try to investigate what their world is around them. You have to be able to put these arguments in a way that they can understand. And the way that, well, my children at least learn the best is through reality, through demonstrations, through something they can touch, feel, taste, manipulate, hear. It is things right in front of them that they can see. And by having a demonstration, which is putting something through the scientific method, that's the best demonstration you can have, because that's a hypothesis test. You've got the dependent variable, the thing you observe, and you're wondering why you're observing that thing, what causes that thing that you're observing. And when we can put something through the scientific method, that is an empirical test. You don't have to believe what is happening. It doesn't require a belief. It doesn't require imagination. All it requires is for you to prove the cause of an effect, and science absolutely proves things. So you've got your alternative hypothesis. You're stating an affirmative claim that the cause, the IV, is the cause of the DV, the observed natural phenomenon, and you're going out to prove that, or you're trying to prove the null, which is the contrary claim that the IV is not the cause of the DV. And by proving one of those, yes, you are disproving the other one, which we get told that science disproves things. But is in disproving something, you are also proving the contrary claim. So you're either proving the alternative and disproving the null, or you're proving the null and disproving the alternative. So science absolutely proves things by way of, if you want to say it disproves things, but it absolutely does prove things. And that is the only empirical method that we have at our disposal to give to people investigating these things. So if this has already been done, which there is a lot of scientific proofs for things that have been done, that you can just, if you are investigating an issue like this, like relative density disequilibrium, it has been put through the scientific method. You can do it yourself. It is an easy test. We've done it here at home. Our kids have done it here at home. We need that to happen on the other side of this argument, which is the dielectric, the incoherent dielectric acceleration, or whatever they're calling now, the electrostatic downward vector. That's what we need to take this, for anyone to take this claim seriously. Yes, there are electrostatics working in our world, but for it to be the cause of something, that's where it needs to be put through the scientific method. And this is why we need to have these conversations, because on one side of the argument, we've got relative density disequilibrium, which has been scientifically proven to be the medium causes the effect of things moving. But as I said, we need for the other side of this argument to be put through the scientific method to be taken seriously. And at the moment, it is as if we are talking to people on the side of the globe. We have science on our side, and they have just those stories on their side. And it's a frustrating situation to be in, because we're not trying to have personal attacks on these people. We're just trying to get into a situation where we can agree on what is actually happening in our world. And that is exclusive of the globe conversation. We don't need the globe conversation anywhere near this, because nothing in the globe model has been proven to work. Nothing has been put through the scientific method. It is just whether you be, Thought Anthony was trying to join there. Yeah, sorry, whether so the globe does not come into this conversation. It has been proven time and time again not to be in existence. We have got the top 3 globe killers being lack of Coriolis effect, gas pressure having to exist in a container, and the number 1 being the black swan. And they absolutely destroy the globe. And now we can go into flat Earth proofs that absolutely prove that we are on a flat Earth, because we can categorically claim that there is no globe. There is no globe model. We do not live on a globe. There's no curvature. There is no spin. There is no vacuum of space around us. That has been thoroughly debunked. We are now on the path to proving the things that we don't know. Some things we can't prove. I don't think we're ever going to prove why the sun moves, why the moon moves, why the celestial bodies move. I don't think that's something that we can prove. That firstly, to put them through the scientific method, they have to be tangible things for us to manipulate. Or the cause of them moving has to be a tangible thing for us to manipulate. The IV, the cause, the things, they need to be actually in existence in the first place to put things through the scientific method. You're back, mate. I was just about to end if you weren't coming back.
Just read me back what Arwin said, because Arwin started saying something, that comment that Arwin said. He's bang on the money.
About the weight. Weight is actually air weight. There's also water weight, vacuum weight. That one.
He's right, because weight is medium specific. They don't tell you that when they calculate weight being mass times acceleration due to gravity, because mass is always a quantifier number, its magnitude multiplied by the acceleration due to gravity. Well, what it should be is mass divided by or multiplied by the density of the medium, depending on which one's more dense and which what. That's really what it is. But then they say, oh, well, that's specific gravity. Well, specific gravity is basically what we are talking about, but their definition of specific gravity is a unitless ratio, which makes it not correct, which on their definition of specific gravity is correct. It is not what the explanation is. It is incomplete, but it's intentionally incomplete so that they can say, well, it's not the explanation, then, is it? Well, it's because your explanation of specific gravity is incomplete. But back to Bob, the argument, the main thing against Bob's point is that essentially it is because it's not linked to, it's not proportionate to mass. Although it exists, it's such a small charge or small force, it isn't worth talking about because it's not linked to mass. It's not linked. It's not like gravity is proportionate to mass. It's not proportionate to mass, and it needs to be the explanation for why there's that little kick that he talks about, and it's just not true.
Yeah, when you were going, I was just making the comparison. It is almost like when we have this conversation with that side of the argument, it is almost as if we're having a conversation with a glober, because like a glober, all they have is a just so story, something that hasn't been put through the scientific method. But on this side of the conversation, we do have science to back it. We do have empirical proofs. And for us on this side of the conversation to take the incoherent dielectric acceleration or a downward bias or anything of that nature seriously, it needs to be put through the scientific method. It needs to be proven empirically, because that is the standard that is the benchmark now for this conversation. This relative density disequilibrium has been proven empirically through the scientific method to be the cause of why we see things move, and that is exclusive of a downward bias.
If Bob's listening, which I'm sure he'll get wind of this conversation, if you're an honest guy, Bob, you will come back to us with an explanation for, given that the static charge potential, or whatever it is that you call it, whatever that name is, right? If it is not proportionate to mass, and it cannot be the reason for the acceleration kick that you describe, why do you not accept that it is limited only to very, very tiny like little tiny masses? Babies can't push locomotives. Just because they're putting a force on it doesn't mean that it's going to move. Well, your incoherent dielectric acceleration is the baby pushing a locomotive, which would be any other mass greater than the fleck of paint. If it's not proportionate to mass, which it's not, it is not the explanation for why there is the little kick. Now, you can think that there is, but unless you can demonstrate it, Bob, which is why I've asked you to demonstrate it, you've got to accept that your null hypothesis is always proven to be true. You just don't like doing it, Bob, and that's the problem. Well, that doesn't mean that it's my fault. It just means that your explanation for why there is an up and down is not true. Bob, I didn't do that test, that egg test, to ruffle your feathers in any way. It was done against ball earthers. And I never expected that you would be my biggest number one enemy, but you've become my number one enemy because you're saying that it's incomplete, or it's not the overall thing. There's something else that gives it a little kick, but you refuse to do the science that's required to prove your claim. And I've done the science that proves your claim to be false. The very least you can do is repeat that egg test with the charge potential that you claim is necessary, caused by current or voltages or amperages or whatever you want to call it, and then see if you can reproduce the results. Because I tried to do it and it failed. I might have been biased against your model and didn't do it properly, but it doesn't do it, Bob. So the least you can do is repeat that egg test with your claim and apply it and see whether or not it causes acceleration. But if it doesn't cause acceleration, Bob, you've got to come out publicly and say that I tried to do it and failed, and it is not complete. It doesn't explain it because it's not proportionate to mass.
And at the very least, I was describing where this conversation needs to go. So where I see, to sort anything out, you need to have both sides of the argument talking to each other. You can't just have 1 week like I had Bob last week, just describing his side. I've got you this week describing your side. To further this conversation for the good of just investigating what it is that we're seeing around us, we need to have these two sides of the conversation. We need to have you and Bob in the same conversation, just sorting these things out. There's nothing personal about this. It is purely just a flat earth discussion, and that's how I see we can further this conversation, because it is exclusive of the globe. We don't need to bring globers in on this. We've thoroughly debunked every globe notion that there is. It's not something, they're just, at the moment, they're just proven liars. And for us on this side of globe versus flat earth, we don't need the globe argument anymore. We're just making fun of them, and we're trying to investigate our reality around us.
So I've been trying to get this conversation for the longest of times, and Bob tells his fans or his followers on his channel that I'm running away. I will not speak to him because I'm whatever. But I'm not running from you, Bob. I might have you blocked because we can't talk privately like adults. But when it comes to publicly, I'm here ready and waiting for you to challenge me. And I know that you won't do it because I've already tested your claim and it fails. Well, if I've tested it and it fails, it's for you to prove that you can test it and it works. But you won't do it, and you won't have the conversation, but you'll tell everybody that I'm running from you or hiding from you because I've got you blocked or whatever. Bob, I'm here waiting for you, and I have been for years. But I never thought it would be you that would be doing it. I thought it would be the likes of the Rumpus or, I don't know, M. Scott Veach or whoever. I never, ever thought that you would be my main opposition. But if you are my main opposition, I'm ready, Bob, and I've been ready for years. Stop hiding and start talking, and let's get this issue addressed and stop running.
Yeah, that's where I see the conversation needs to go. So is there anything else on the side of relative density disequilibrium that you have not gone into that you would like to highlight? Anything that you've been working on? Is there any further improvements to, well, the egg test has been proven empirically. I'm not sure if you can improve on that, but is there anything else you're working on at the moment?
It doesn't need any refining at the moment because nobody's come up with any demonstration or any criticism that's valid to demonstrate why it needs to be refined. It explains the cause of the direction. And again, up and down, Bob, They're not absolute directions. By definition, in practice, in day-to-day life, they're not. So we just use it as a term to describe the way that things are moving. The correct units really are more dense, are less dense, and we can prove it. It's demonstrable, it's repeatable, it's verifiable, but it's not caused by static charge potential or whatever it is. So it doesn't, my model doesn't need any refining. It's right. Bob's model needs to be demonstrated to be true, and it doesn't do it because it's not proportionate to mass. That's like the bottom line. It doesn't get any more black and white than that.
There's just one thing I want to kind of define. Like, so you mentioned magnitude. What do you mean by magnitude in this conversation? Why is magnitude so important?
So a ping pong ball and a golf ball have the same volume, but they don't have the same magnitude. It's a quanta of mass. It's a measurement of mass. It's a value that we put to something to represent weight. It's a ruler for how heavy something is, but in the context of mass. And a ping pong ball, although it has the same volume as a golf ball, because they've got different magnitudes or different measures of mass or different magnitude is just a measurement, it's quanta. And it's that quanta that we're talking about that causes the difference in movements between mediums and objects. It's just a measurement.
Beautiful. There's this one other thing I want to mention. Arwen has sent in the chat. If density differential is near to nothing, then pressure differential will be near to nothing. If density differential is maximized, then effective weight will be maximized.
He's absolutely correct.
Yeah, it's a brilliant point. And it's things like this. We're having these conversations where we're refining. We've pretty much refined our argument as far as it can go. You've put through the scientific method, like you said. There hasn't been any pushback. There hasn't been any repeating on the opposite side. To I'm not sure. There's been no opposition, no actual scientific opposition to relative density disequilibrium, and that's what we need, because at the moment that is the standard on the table, and that's what we need if there's going to be two sides of the argument. There can't be just so stories. There can't be stories that lead to people saying that gas does go down, whether it be in the medium of a vacuum, whether it be in any sort of situation. Gas does not go down. It goes.
It's omnidirectional, isn't it? In all available directions.
Exactly, and if it is going down, that violates every natural gas law, and we would not have those natural gas laws. The fact that we still do have those natural gas laws, that's not science, that is just natural laws, something that we always observe and never not observe. That's why they're natural laws. It'll be violating those natural laws.
I did hear Bob comparing, he said, like, if you get multiple gases in a container, in a big container, and left them to settle for a long enough period of time, he said that they would form layers. Like, they're not hard layers, they're like a gradient layer. And he's right, that does happen. Why does that happen though? And he thinks it's because they lose energy over time and slow down. Well, the bit that he's ignoring there is that gas molecules, when they collide with each other or with the walls of the container, they have perfectly elastic collisions. They do not lose energy over time. The reason why these things form out what looks like smudgy layers that are not hard layers, and he's right with that, it does do that, is because of magnitude. You've got gas molecules, say you've got three gases in a container, right, of equal volume. And let's just say you've got fat gas, you've got normal gas, and you've got skinny gas. You instantly know what is going to happen with that. You're going to have fat gas towards the bottom, you're going to have the normal gas somewhere in the middle, and you're going to have the skinny gas up at the top, right? Why is that? It's because of the atomic mass of the object in question. The molecules in question have got mass, and because they're inside a container, and because they've all got different magnitudes of that mass. You've got fat man at the bottom. Fat man can't stay at the top because little man can't hold up fat man, right? That's literally, so I'm like, Arwen's a skinny guy, Bob's a big guy. If Arwen and Bob are in a container and there's someone like Nathan that's in the middle, that's kind of like in the middle, he's neither fat nor thin, he's kind of in the middle. You know which way it's going to lay it, because why? Because Bob's magnitude is greater than Nathan's, and Nathan's magnitude is greater than Arwen's, and Arwen can't hold up the other two. So Arwen's going to get displaced by the other two. Why? Because mass. This is where Einstein was actually correct. the uneven distribution of mass, the distribution of mass causes acceleration. And he's right with that. He just applied it into space-time. But if we apply it onto Earth time, then we see relative density disequilibrium. So that is the reason why we have the layering. It's because fat man at the bottom, middle guy in the middle, and skinny guy at the top. The skinny guy can't support the other two guys because he's not strong enough. He hasn't got enough magnitude behind him to be able to do it. So it's because of that property of matter, magnitude, that is the thing that causes the direction. Now, we perceive it as up and down because that's how we call it. But it's the intrinsic matter, because magnitude of mass exists, because it exists, it causes that movement. It's because weight is weight. It's that simple. And that I just don't I don't understand how Bob can see the layering effect and the density gradient between 2 or 3, 5 gases being like some kind of something that's influencing the up from the down, when it's literally the magnitude in question that's the cause. But I don't know. I honestly don't think Bob accepts magnitude exists, because to argue what he argues indicates that he doesn't accept that magnitude is a thing. And unfortunately, mass by existing has magnitude, and that difference in magnitude, subject to the volume, is the reason why when you have two things together competing for the same space, we get that effect. That is the cause. It's obvious.
Well, the only person that can answer these questions is Bob. We can't put things in Bob's mouth. He has claimed that what he has claimed, and to further this discussion, you two need to have a serious conversation about this. I'm prepared to moderate it. I'm sure a lot of other people are prepared to moderate it that you guys would be comfortable with. I'm sure. I think you're comfortable with any time, any place. Is that right, Anthony?
I don't even care if you get a ball there to moderate it. I don't care whether it's you, Mitchell, or whether it's one of Bob's cronies or one of Nathan's cronies. I don't care who does it. The simple question that needs to be answered by Bob is it proportional? Because your claim is not proportionate to mass, it cannot be the kick that you claim it is, because it's not proportionate to mass. If it was proportionate to mass, maybe there'll be a conversation there, but it's not. It's not proportionate to mass, so that excludes it from being. All he's got to do is answer that question, address that criticism, and then we don't even need to have the conversation.
And we've lost Anthony again. Perfect timing, Anthony. And yeah, so at the third of this conversation, getting personal, which it isn't personal. There's nothing personal about this conversation. This is purely on topic. It is purely just relative density disequilibrium versus incoherent dielectric acceleration or downward bias or whatever it is on that side of the argument. Now, that's where this argument is heading. I want to thank you, Anthony, for being here before your internet drops out again. Really appreciate your demonstrations and your explanations and the science that you've put into this. It's on the table. It's there for anyone to do themselves at home. It is a simple experiment, and it is an experiment. Thanks, Anthony. Is there anything else you want to go into?
Yeah, do us a favor, when you upload this video, just chop out all the bits where I'm cut off it, because otherwise it's going to be it's going to be awful. Just chop out the bits where I'm not on the screen and then bring them back in so it looks like it's continuous.
What bits of the internet?
You'll have to put in a disclaimer. This video has been edited not to cheat, but because the ISP was playing Gremlins today.
What bits were your internet dropped out? There was no bits. All right, thanks, Anthony. Thanks for being here. Thanks for everyone viewing this. If this will be out on my my channel publicly after the fact. Appreciate your time, Anthony.
No worries, dude.
Catch you later, mate.
In a bit.